We're going to move on to side ratios now. So we have our special right triangles. So before we get into the side ratios, I did want to mention these. These are common on assessment type questions, and even something like MCAS and stuff. Um, but they usually give you a formula sheet. But if you can use it without referring to the formula sheet, you're only going to save yourself a little bit of time. So we have a 45, 45, 90 right triangle. So what that means is if one leg is X, the other leg's going to be X, right? We have matching angles here, the base angles, like an isosceles right triangle. So we have X, X, the hypotenuse is X root 2. They do root 2X, which I don't usually like because, unless you're pretty clear, the X could be underneath, the X might not be underneath. But it's X root 2, that's usually the way that we see it. And then a 30, 60, 90, the shortest leg is X and the hypotenuse is 2X. The trickiest one is the longest leg. A lot of people kind of confuse these two. The long leg is root 3X. I like to usually say X root 3, but here it's root 3X. Just again, the X is not underneath the root. That's why I like putting it out in front. But these are ones you want to memorize for this lesson. So we have 45, 45, 90, X, X, X root 2, and then a 30, 60, 90, X is the shortest. 2x is the longest for the hypotenuse, and x root 3 is the longest leg, but not the longest side. So quick on your own problems. Spend about a couple minutes doing these. Solve for the missing variables. Again, don't take too long with these. We do have a lot of stuff to kind of get through today. But take a good 5-6 minutes and solve for these, and then start the video back up after everybody's done. All right, so this on your own, I wish I probably should have put things here, but you should have found that with a 45, 45, right, two legs are the same. So B is 2 root 2. Number 2, we have a 30, 60, 90. Doesn't give you 30, but you should be able to figure it out because this right here denotes 90 degrees, 60 degrees. That means this one would be 30. So our shortest leg is Y, which just means 8 root 5, which is the hypotenuse, is 2Y. So you have to solve for x. So basically what you want to do is say, okay, well, 8 root 5 is 2y, so that just means 1y would be that divided by 2. So that's y is going to be 4 root 5. And then if you have to find x, basically x is going to be 4 root 5 root 3. Right, so if x, in this case x is y, which might be kind of confusing, but this right here, shortest leg is 4 root 5, so we just want to take 4 root 5 and multiply it by root 3. And when you do that, you'll get 4 root 15, which is x, and you can't break that down any further. Number 3, we have a 30-degree angle. That's our 60, that's our 90. So the long leg is 12 here. So normally the long leg is x root 3, so you want to say 12 is equal to x root 3 and actually solve it for x. You don't have to solve for x in this case because actually it's going to be y. Y would be the shortest leg. So you could say, 12 is equal to y root 3 and then solve it for y. So when you divide 12 by root 3, you're going to get a root 3 in the denominator. So you want to rationalize it, but you should end up with 12 root 3 over 3 for y. And then if y is 12 root 3 over 3, that just means your hypotenuse is going to be, well, actually, I'm sorry, 12 root 3 over 3 we can simplify. I should have caught that. 12 root 3 over 3 is going to be 4 root 3. So your hypotenuse would then be 8 root 3 because your hypotenuse is twice as much as your shortest leg. So again, 12 root 3, well, this is 12, and then say, okay, well, 12 is equal to y root 3. Solve it for y, you get 4 root 3, and then double it to get x, which is going to be 8 root 3. And again, feel free to pause the video if that was too fast. Sometimes not seeing it out might make it a little harder, but you should be able to kind of get the gist of these. This one, they give you 45, 45, 90. They give you the hypotenuse. So m and n, are going to be the same because it's 45 and 45. So you just actually have to solve them. So again, this one here, we have x root 2, and they give us that. So I would say 7 equals x root 2 and solve it for x. So when you do it that way, you're going to get x root 2 equals 7. Divide by root 2 over root 2, or divide by root 2 on both sides. You're going to get x equals 7 root 2 all divided by 2. That's what n is, and that's also what m is. Again, they're going to be the same. This is an isosceles right triangle. Last but not least is number 5. Number 5, they're giving you 11 root 3, which is actually nice of them in this case. We have our 30, 60, 90. So 11 root 3 corresponds with x root 3. So what does that mean x is? That's going to be an 11. So in this case, our x that we solved for, we can also just say it was b. So b is 11, which just leaves a is equal to 22. All right, next slide. So today we're going to be working with right triangles. Obviously, with right triangles, all the angles that we're going to work with are going to be acute, right? We're not really working, well, the 90 degrees obviously is fundamental. But we want to know all of the trigonometric side ratios of the acute angles. Obviously, there's no obtuse angles. All the angles add up to 180. So if you have a right triangle, that's 90 of your 180. It only leaves you 90 left. So two angles have to add up to 90. That just means they're both going to have to be acute. So I do have another video. It's a video inside a video, if that doesn't blow anybody's mind, that we're going to watch. So here's a reminder of what our 6 trigonometric side ratios are. Again, something you covered in geometry, but it's been a little while, so definitely take notes on this stuff. These are big ones. If you need to, this video is kind of slow to load. You can feel free to fast forward until you get there. Oh, that actually wasn't too bad.
Go to the other 3 trig ratios, which you could think of as the reciprocals of these right over here, but I'll define it. So first you have cosecant, and cosecant...
Not really sure why that decided to start at 3 minutes and change, but we'll start from the beginning.
Trigonometric ratios for angle A in the right triangle below. So this right over here is angle A. It's at vertex A. And to help me remember the definitions of the trig ratios, and these are human-constructed definitions that have ended up being very, very useful for analyzing a whole series of things in the world. But to help me remember them, I use the word SOHCAHTOA. So let me write that down. So, SOHCAHTOA. Sometimes you can think of it as one word, but it's really the 3 parts that define at least 3 of the trig functions for you, and then we can get the other 3 by looking at the first 3. So tells us that sine of an angle, and in this case it's sine of A, so sine of A is equal to the opposite, that's the O, over the hypotenuse. Opposite over the hypotenuse. Well, in this context, what is the opposite side to angle A? Well, we go across the triangle. It opens up onto side BC. It has length 12. So that is the opposite side. So this is going to be equal to 12. And what's the hypotenuse? Well, the hypotenuse is the longest side of the triangle. It's opposite the 90-degree angle. And so we go opposite the 90-degree angle. Longest side is side AB. It has length 13. So this right over here is the hypotenuse. So the sine of A is 12/13. Now let's go to CA. CA defines cosine for us. It tells us that cosine of an angle, in this case cosine of A, is equal to the adjacent side to the angle, over the hypotenuse. So what's the adjacent side to angle A? Well, if we look at angle A, there's 2 sides that are next to it. One of them is the hypotenuse. The other one has length 5. The adjacent one is side CA. So it's 5. And what is the hypotenuse? Well, we've already figured that out. The hypotenuse right over here, it's opposite the 90-degree angle. It's the longest side of the right triangle. It has length 13. So the cosine of A is 5/13. And let me label this. This right over here is the adjacent side. And this is all specific to angle A. The hypotenuse would be the same regardless of what angle you pick. But the opposite and the adjacent is dependent on the angle that we choose in the right triangle. Now let's go to TOA. TOA defines tangent for us. It tells us that the tangent of an angle is equal to the opposite side over the adjacent side. So given this definition, what is the tangent of A? Well, the opposite side we already figured out has length 12, and the adjacent side we already figured out has length 5. So the tangent of A, which is opposite over adjacent, is 12/5. Now we'll go to the other three trig ratios, which you could think of as the reciprocals of these right over here, but I'll define it. So first you have cosecant, and cosecant, it's always a little bit unintuitive why cosecant is the reciprocal of sine of A, even though it starts with a co, like cosine. But cosecant is the reciprocal of the sine of A, so sine of A is opposite over hypotenuse, cosecant of A is hypotenuse over opposite. And so what's the hypotenuse over the opposite? Well, the hypotenuse is 13, and the opposite side is 12. And notice, 13/12 is the reciprocal of 12/13. Now, secant of A, it's the reciprocal, so instead of being adjacent over hypotenuse, which we got from the ca part of SOHCAHTOA, it's hypotenuse over adjacent. So what is the secant of A? Well, the hypotenuse, we've figured out multiple times already, is 13. And what is the adjacent side? It's 5. So it's 13/5, which is once again the reciprocal of the cosine of A, 5/13. Finally, let's get the cotangent. And the cotangent is the reciprocal of tangent of A. Instead of being opposite over adjacent, it is adjacent over opposite. So what is the cotangent of A? Well, we figured out the adjacent side multiple times for angle A. It's length 5. And the opposite side to angle A is 12. So it's 5/12, which is once again the reciprocal of the tangent of A, which is 12/5.
All right. Hopefully that video was good. Just kind of reminding ourselves what those are. Now again, the when he does the reciprocals, you can think of cosecant, as also, cosecant's going to be hypotenuse over opposite. You can think of it as the opposite of sine, which is opposite over hypotenuse. But we can also write it as 1 over sine, and you will see some like this instead, but it's really the reciprocal of sine the same way. And how does it work mathematically? Well, since sine is opposite over hypotenuse, and cosecant is 1 over sine, it's 1 over opposite over hypotenuse, and just think of it as 1 times the reciprocal of this, so 1 times hypotenuse over opposite. It gets you to here. And it works for secant as well, 1 over cosine, which is 1 over adjacent over hypotenuse. Again, if you actually go ahead and simplify that out, you get hypotenuse over adjacent. Cotangent is 1 over tan. It's going to simplify to adjacent over opposite, which is the opposite, or the reciprocal of tan. But definitely want to know them both ways. Depending on the wording of the question, you're going to have to figure it out both ways. So know that hypotenuse over opposite is cosecant, as is 1 over sine, right? They're the same thing. So you do have some partner practice problems. These might take a little while, so take as much time as you guys need. Obviously, keeping track of time and how much time we have left. But I do want you to find all of these angles here, or all of these basically trigonometric ratios here. So take a few minutes. You can work in partners. Stay close. I just don't want you moving up and spending a lot of time doing that. So you can just work with the person next to you. That'd probably be the easiest for this part. And then pause the video. Once you guys are all set, we'll resume the video and go over these numbers 1 through 8. All right, so tan z was the first one. That's this angle here. So tan z, opposite over, oh gosh, I was going to say hypotenuse. Tan z, opposite over adjacent, 21 over 28. And you guys want to make sure that when you do this, you simplify. Don't leave it as 21 over 28. Simplify it. Factor out a 7 out of there, both of them. You should get tan z equals 3/4. Number 2, cosecant c. Cosine c. So here's our c right here. Cosine is going to be ca. That means adjacent over hypotenuse. 16 over 34, which you would want to reduce to 8 over 17. Sine z. We have our z up here, so sine, opposite, sine so opposite over hypotenuse, 24 over 40. You can take an 8 out of both of those. That should reduce to 3/5. 4, we want cosecant c. So cosecant c, I'd want you to think of, okay, well, that's going to be the opposite of sine. So sine is opposite over hypotenuse, so cosecant would be hypotenuse over opposite that way. So that's going to be 37 over 12. Can't reduce it. That one's just going to be 37 over 12. Number 5, cotangent of x, that's going to be adjacent. So adjacent to the x is a 30 over the opposite, 30 over 40. We actually get 3/4 just like we did here. Secant A, I think, okay, secant, what's the opposite of that? What's the reciprocal of that one? Well, that's just going to be your cosine. So secant of A, right? Cosine of A would be adjacent over hypotenuse. So secant of A is hypotenuse over adjacent. So you'll get 29 over 20. Can't break that down any further. Cosecant A, again, another opposite of our sine function. So we have A here. Sine would be opposite over hypotenuse. Cosecant, therefore, is hypotenuse over adjacent. 45 over 36, you could reduce that to 5/4. And number 8, secant of A, again, secant is the reciprocal of cosine. So cosine is adjacent over hypotenuse. Secant is going to be hypotenuse over adjacent. So 45 over 27, reduce that down to 5/3. So those are the 8 partner practices. You want to get pretty quick at doing these. You don't want to get hung up on doing these, especially come, a quiz time. These ones you kind of want to be able to fly through. So let's look at one like this where we need to figure out an angle. So we have a ratio of the sides. You got to figure out which trigonometric side ratio you want, but now we have to find an angle. So step 1, determine the side ratio you want to use. So you have an opposite and an adjacent. So I picked tan. You could say cotangent. Usually the big three, the main three are sine, cosine, tan. Those are the 3 that you have the most access to on your calculator, the easiest access. So I would say tan would probably be the best, but if you said cotangent, that's fine. Step 2, plug the values in. So you're going to have tan of the angle. I use x here. Normally we're going to abbreviate an angle with a theta. I don't know if it's in the next slides coming up, but I'm going to say x degrees. But normally we'll probably see theta, but we'll say tan of x equals 27 over our 38. And basically what we need to do there is use the inverse operation to determine the angle measure. Now this is an example with sine, but it works for tangent and cosine just as well. Now again, this sine with a -1 as an exponent does not mean 1 over sine, right? 1 over sine is what cosecant means. That's not what this means. So it's almost like when we had f with a -1 exponent of x. That doesn't mean 1 over f of x. That just meant f inverse of x. So this is the same thing where I don't want you to think of sine to -1 as 1 over sine. That's not the case. It's just an inverse. So you want to use the inverse operation to determine the angle measure. So the angle, right, normally we'll have an angle and you can use your sine function, opposite over hypotenuse. This one here, it's kind of working the opposite way where we have the ratio opposite over hypotenuse for sine. Here we have a tangent opposite over adjacent. We can do the inverse function to get the angle. So it's kind of working the opposite way. So the 6 trig functions take angles and tell us the ratios, right? So we can take an angle, get the ratio from it, but the inverse trig functions are basically taking the ratio and giving you the angle, which is exactly what we're doing here. So in this case right here, we have tan of x, right, from here, right, our 27 over 38. So what we want to do with that is now do the inverse function or the inverse operation here. So we get x by itself by doing tan, or the inverse tan of 27 over 38. And basically from there, that's a button that we can use on our calculator. It's basically second tan, and that will get us the inverse tan. And when you get it that way, you get 35.4 degrees. Now, I will say this, you want to round to the nearest tenth of a degree. When in doubt, nearest tenth of a degree. For now, we're going to do some with minutes. That'll be the next day. But 35.4 degrees. Now, if you didn't have that, oops, I just extended page. If you didn't have that, you might have gotten an answer like 0.617755. So if you got that, raise your hand. Nah, I'm just kidding. You don't really need to raise your hand. But if you did get that, what you need to do is set your calculator to degrees and not radians. So you hit the mode button right there. I got an arrow drawn right to it. The third one down is going to say radians for you if you had this answer. We want degrees. You do want to know how to go back and forth. If I ask you to label something in radians, you're going to want to use that, but that's not going to come up for a little while. But the degree button is what you want to highlight. So hit to the right arrow, hit enter, and you should be all set. You can try the problem if you want again and make sure you get the answer of 35.4 degrees, but that should work. Now, so what you're going to do is you have a classwork, not a classwork activity, but you do have a classwork assignment. I'm going to pull it up here. I want you to finish this for homework if you don't complete it in class. Now, you can work with partners. So to pick a different processing partner, I'll put Nikki in charge. Nikki, pick a processing partner. And this is what you're going to be doing. This was your classwork, actually. Hold on. You do have, yeah, a little activity here. It's a inverse trigonometric ratios. It's not too long. It does have 2 pages, and what you will see are different activities. So find the angle measure. So you just type in basically what you want to do here. You have sine of A equals 0.5150. That's almost like your ratio, after you simplify it or get a decimal for it. So you need to do inverse operations here. Find the measure, same thing. You're going to have to do some inverse operations. That's pretty much what